Hey everyone, welcome back to my channel, Everything IoT Hacking and Hardware Hacking. My name is Joe. I just want to apologize for the long delay in videos. I was doing a little bit of renovation, a little bit of carpentry work in my office space. I'm not a carpenter. So it took me like a month and a half to do something that a real carpenter probably could have done in like 2 days. So hats off to real carpenters. Hats off to real carpenters. It is not as easy as it looks. But today what I want to do is I want to show a command injection vulnerability that I found on this old router that I got from a thrift store. As a disclaimer, I did look it up. It already has been found. Darn it. It already has been found, so I'm not breaking any disclosure rules or anything like that. I don't want to get put in the slammer, but I want to kind of share with you my thought process and how I found it and how I went about it. So maybe somebody can learn something, because I know I learned a lot off this, and I'm not the greatest master IoT hacker or whatever, but I thoroughly enjoy doing it, and I like to share any sort of knowledge that I can. So maybe it'll help somebody. But anyways, let's go ahead and get started. I'll show you what we're working with. All right, so here it is. This is a Netgear WNR-2020 router. As you can see, I found the UART interface here. It has root access, which is great. I'm using a Hydra-Bus here to interface with UART, and Hydra-Bus is like an all-in-one IoT hardware hacking tool. It's kind of like a bus pirate, but with a little bit new and updated hardware. So here's what we're working with. I already have it all torn apart. I already soldered on the pin headers and whatnot. So let's go ahead and jump over to the UART shell. Here we go. And as you can see, we are running as root. All processes are running as root, so that is good. You know, it's an old router, so it doesn't have a lot of security precautions or anything like that. It is running a Linux operating system with a squash FS file system, so that is good. If you're familiar with Linux, then you're going to be right at home here. But what we're going to do is talk about UART and why it's so awesome for. Obviously, getting a root shell anytime is awesome, and it's great to have. But what happens is the manufacturers and developers will add into their code the debug console messages that will print out to UART. So if they have any sort of errors or problems, it'll tell them what's going on, and it'll give them any error messages, and they can get a feel for how that the system is running and if they need to fix anything. Now, we as hackers, we can use that as well to gain an understanding on how that the IoT system is functioning, how it's working, what's going on the back end. And what we do, what I do first is I will take an IoT device, if I get a UART interface like this, and I will actually use it as a normal user would. So in this case, it's a router. It's going to have an administration panel. So I'm going to go through the administration panel, and I'm going to make a change, apply the change, and then see what happens on the back end. So I can try to gain a better understanding of what's happening. If there's anything interesting being ran, do I see any custom like programs being ran, or just anything like that. All right, so let's jump over to Kali and get into the administration panel and play around with it, make some changes, and see what happens. So here we are in Kali in the administration panel, and we'll just go to internet here. And the first thing I'm going to do, I'm just going to click apply and see what happens on the back end. So let's hit apply here, and let's jump over into the UART shell. And as you can see, a bunch of stuff's happening here. And one thing that instantly catches my eye are all these system calls. It looks like that the device, for the most part, is using Linux commands to do all the configuration. So let's scroll up a little bit up to the top here. You can see this RC command's getting ran. It's stopping the WAN file. There's a bunch of system calls using regular Linux commands. It's killing processes. It's restarting the WAN interface back up. It restarts its CP. It does a bunch more of configuration. So all this is really good information. It's giving us a feel for what's happening. So what it looks like is it brings out a bunch of interfaces, it kills a bunch of processes, it's making a change, and then it brings everything back up again. So that's really good information to know. All right, so let's jump back over into Kali and go ahead and make a change and then see what happens if we do an apply. And what I'm going to do is use the MAC address down here. I can use a custom MAC address, and let's get rid of all this junk. And I'm going to put this in here and see what happens, and see if we can see this input being injected into a command on the back end. So let's go ahead and click apply, and then we're going to see what happens. As you can see, it's doing its thing. It's bringing systems down. It's bringing systems back up. So let's scroll up to the top. I think it started about right in here. So same thing's happening. It's killing a bunch of processes. It's bringing a bunch of processes down, and then it's bringing it back up. I see a bunch of system calls. So that is good. Right here, look at this. Very interesting. That user input that we did is being injected into the back end. So are we able to add a Linux command on the end of that MAC address? Will that work? So why don't we go test it and find out? Okay, back over in Kali. Let's go to the end of our MAC address and let's try to add and ls. So oh no. So I cannot add any characters at the end of this. This input box probably has a character limited. What if we just erase this and then do and ls? Let's go ahead and try this. If you don't know Linux commands, I suggest you stop and go learn how to do all the basic commands, how to chain commands together, because the and sign will chain commands in the command line together. So let's hit apply, and we get invalid MAC address. So there's some sort of user input validation or sanitation going on here. What we need to figure out next is if it's client side, is it server side, or it could be a combination of both. So one easy way to check is to go to inspect. We can go to the network tab here and try again. So let's hit apply, and invalid MAC address. I do not see any server calls going out to the server or out to the router. So that means it must be client side. So more than likely, well, not more than likely, I already looked. It has a JavaScript file that handles all the input validation. So one thing we can do now is to go into Burp Suite, capture the request, modify it, and then see if we can inject the command. So let's go ahead and try that. All right, we got Burp Suite loaded. Let's go ahead and turn intercept on. We're gonna turn on Foxy Proxy. I went ahead and put the custom MAC address in so we can easily catch it, and let's hit apply. And Burp Suite captures the request, so that is good. And if we scroll down a little bit, you'll see our spoof MAC address, which is our custom MAC address. It's right here, AA, BB, CC, blah, blah, blah. Now you can see all the funky characters in there. It is URL encoded. So that means whatever command we're going to attempt to inject has to be URL encoded as well. I already have that done. You do a quick search for URL encoder on Google and a bunch will pop up. And right here is our command that we're going to attempt to inject. It'll be ls and pipe the output of that into temp into the Haxerd file. So let's go ahead and get that there. We're going to come here. Now it has to be right on the end of FF. If I can actually click it. There we go. So there we go. We have our custom command in there. So let's go ahead and forward that off, jump back to the back end and see what happens. All right, let's go to the shell, and here you can see exactly like what we did before. Everything's stopping, restarting, killing processes, bringing them back up. And let's go look for our custom right here. and it appears that it's something. I don't see any errors, so let's go into the temp directory and see if it actually worked. And bam, look at that right there, hack search. So that is a successful command injection right there. And then we can cat that up. And there we go. So that is a successful command injection vulnerability that is found. So at this point, we have an injection point. So sky's the limit. We can run any command we want as root. So why don't we set up a little bit of persistence now? This router, it has telnet installed. So why don't we open up a telnet port, and then we could just telnet in at any time we want and have root access to the device. So let's go ahead and do that. Okay, back over to Kali. Now let's do the exact same process, but this time we're going to inject a telnet command that will open up a port for us and give us root access, so we don't have to go in through UART anymore. So same thing, we're gonna go ahead and get burp up, and we're gonna turn intercept on. I'm gonna turn my Foxy proxy going, and then we're gonna apply, capture that post request, go back down here to where our injection point is. In this instance, we are going to inject this command right here, and it should have an and on the front of this. Okay, so here's what it's going to be. It's going to run telnet. It's going to open up on port 444, and let's give that a go. So we're going to come right back over to the end of the FF and like this, and we're going to paste that in. Just like that. Make sure that that looks good. Spoof MAC address, everything's looking good. Let's go ahead and forward this off, and we'll go check to see if it opened up a telnet port. Okay, it's going. Let's jump over to the shell here. Here we go, and same thing as before. And right here is our injection point. We have and telnet D. So let's run a PS and see if we can see that process running now. Right here, we have telnet D on port 444. That's awesome. So let's jump over into my Linux shell here and see if we can telnet in. All right, let's give it a go. Hopefully you can't hear the freaking trains that always come by me. There's one coming by us. So we're going to go telnet. Oops. So telnet 192.168.1.1 on port 444. Let's give it a go. The WRN-2020 login. That is awesome. It's going to be root. And how did I figure that out? I just tried all the common ones. Well, root was the first one I tried, and then admin or whatever. All the common login ones. Bam! We now have a telnet shell, full access to the router, full control over the router, and are we running as root? We're going to go echo, and we are running as root. Now you might ask me, why am I not running like user command or whatever? It's because this version of BusyBox in Linux, it does not have it. So boom, there we go. We have a awesome command injection vulnerability that would allow us to get full control of the router. So much fun to find. All right, so let's do a recap here. First, we got our UART root shell. We use the device as a normal user would. We use UART to gain an understanding of what was going on in the back end, how the system worked while we made changes. We discovered that user input was being injected into the back end in a system call. That user input, it was being validated client side, which is good. We used Burp Suite to capture a post request. We modified the payload with our command. We forward that off up to the router, and we own the router and had full control over the router this would be considered an authenticated blind command injection, because when we're injecting the command, we can't actually see any output unless we have a UART shell. So this is a authenticated blind command injection. Super fun to find. As a side note, I didn't find this thing in like 5 minutes. I did a lot of enumeration. There's many other injection points on this router as well. I use that one because of the input is validated, and I thought, you know, it'd be a good teaching moment to show how to use Burp Suite to bypass client side user validation and stuff like that. But I think that'll do it, guys. I hope you like the video. Hope the video is going to turn out good. I'm not, you know, some big time know what I'm doing on making videos and streaming and stuff like that, guys. But I hope you really enjoyed, guys. Leave a comment down below if you have any questions or comments or anything like that. Thanks for watching, guys. Hope you're having a good week. Hope you're having a good year. Hope you're having a good day, guys. Stay safe out there. And that's it for me. I'll see you next time. Peace.